Welcome. We're doing some science experiments today. Let's get this flask filled with some water. Over here on the right, we got the one on the left already filled. I'm adding distilled water. They are both on magnetic stir plates. The flask on the left has some universal indicator added. I need to add some universal indicator to this one over here on the right for sure. Let me get to that. Let's see who's in there. Let me say hello, folks. Sorry. How you doing, Fidro? Gigabean, Arjun, Bujo Bear. That's right, T-Boogie. And Z-Tech, hello. All right, let's add a little bit of universal indicator to this flask over here on the right, shall we? And we'll get going for the day. Welcome aboard, folks. Hello, Gigabean. Here we go. Add a little squirt over here. We're used to seeing that green color at first in the universal indicator. You can see that in the dropper. And as that universal indicator goes into the deionized water, it turns a yellow color, which indicates slight acidity. So Fidro asks, I have one question. Is there any acid that reacts to universal indicator instead of changing the color? So I guess what you're asking, Fidro, just to make sure that I understand, I assume that you're asking that the acid destroys the dyes in the universal indicator rather than just changing the color. What a great question. I am unaware of any of those, but I think it's certainly possible. Now, I can tell you of a base that does it, hypochlorite ion. So hypochlorite ion, which is better known as bleach, that is actually a base. It's quite basic, and yes, that will destroy some of the dyes. Dervis, I'm really sorry to hear that. So Fidro, yeah, I think I answered your question. All right, we're going to start adding either acid or base to both of these particular flasks. The one on the left right now is at a low pH. I can tell that because of the red color, quite low pH. So its pH is 3. And the one on the right is just slightly acidic. That's going to be a pH of 6, just slight acidity. So Fitter also learned from a chemical game and some videos that if you combine concentrated sulfuric acid and a bunch of hydrogen peroxide, it makes piranha solution. Fidro, check out my short videos. I've got a video where I make piranha solution. I don't show you, the process of making it, but indeed I use it, and I use it to destroy a Scrub Daddy sponge. How do you like that kind of thing? All right, let's get going here, man. Let's do some color changes. So I'm going to go ahead to this flask over here on the right. We're going to add a little bit of hydrochloric acid. It's the same acid that's found in your stomach, and goes a drop. And, of course, we see a color change to red immediately. And now I'm going to start adding some base over here on the right. I'm going to add a drop of base. And look at that color change. Get a nice... What's it going to end up? We can see the violet color. I remember you, Sandra. I don't think he is happy anymore either. So you see I added a little bit of base, and now we see a shift from a red to a kind of an orange color. So the pH went up just a little bit. I'm going to add another drop here. One more drop of base to see what happens. Woo, we got a huge color change. Look at that. We went from pH 4 all the way to pH 10. Let's try this one over here on the left. I'm going to add a drop of base. Uh-oh, we got quite a bit of acid over here. Let's add another drop of base. Haven't had quite a bit over here to get some color changes going. You might be able to see just a little bit here. I'm going to adjust this light just a bit. It's a little bit bright. That might help us see what's going on there on the bottom just a bit better. Wow, yeah, that's really taking a long time to change. Start adding some base here. I'm adding drops of base over here on the left. The base I'm adding is sodium hydroxide. Sometimes people call it lye. Come on, man. Nothing's going on. There we go. A little color change, a little rainbow action. Come on, baby. And it looks like we ended up at well, it looks like we're at pH 10 also. So let's start adding some acid. The acid I'm going to add is hydrochloric acid. It's the same acid that's found in your stomach. It's just this stuff is like 1,000 times more concentrated. So I'm adding acid now to the basic solution, and you should see color shift to blue and then green and then yellow. We'll see. What does universal indicator count as a base or an acid? So there are some substances that are both acidic and basic, which means they can both accept protons and release protons. And the dyes in universal indicator behave that way. We call them amphoteric or amphiprotic. So substances that can behave as both acids and bases. Depending upon the conditions, we call those amphoteric. So now I've added enough base to this flask on this side. It looks like the colors may be, pH 7 or 6. Let's start adding some drops over here on the right. Drops of hydrochloric acid that's going to react with the available base. And yeah, this one's color changing quite quickly. Let's add a little bit of base back here. Here we go. Let's add a couple drops of acid over here on the left. We went from pH. Yo, could you explain the 7 gas laws? So Arian wants me to describe the 7 gas laws. So, man. Well, you've got the P1V1 equals P2V2, right? That's a direct relationship, an indirect relationship between pressure and volume. As one goes up, the other goes down. We got P over T, P1 T over T1 is P2 over T2. And we've got V1 over T1 equals V2 over T2. Look at that gorgeous chemical change over there. Have you ever tried the reaction putting mercury on aluminum to make aluminum alginate? I'm not sure that makes aluminum alginate, but I have seen it, but no, I've not done that, which I think is a very interesting reaction. I will say that. Froji says, this is actually some cool demonstrations of how acids and bases work and how to identify them. Good stuff. Hey, thanks there, Froji. Or maybe you're a frog. Maybe you're a frog, so I apologize if I'm saying your name wrong. I do that a lot. A couple of drops over here of acid on the left. Do a couple drops over here on the right. You can see that this system over here is buffered a little bit better. And what that means is it resists changes in pH much better than this system over here. So this is kind of buffered. Let me add, let's see, a couple more drops of the acid. There's another drop. We're going to add some base over here on the right. A couple drops, see what happens. There you go, Ryan. Thanks, Ryan, for clearing that up. That's right. It does make a mercury aluminum amalgam. Appreciate helping me with the confusion there. Good call. Ryan, the chemist, has entered the chat. Got a little rainbow action going. I think we're able to get the rainbow a little bit better over here on the left. Yeah, that's pretty. Very pretty. A little bit of acid over here on the right-hand side. Now we're going to start adding base because we're at the low pH range. I want to change the color, so I got to add base to get it heading the other direction. Looks like we're at like pH 4 over here. Yeah, an orange color. Let's add a little bit of base over here. We're going to have to add a bunch more because this system's buffered. That's all right, Ryan. Hey, you know what? You corrected the chemist. You're a chemist in my book. Or I should say you helped out the chemist. We all help each other out, man. Love it. Put a bunch of minds together on something, and it's always going to work out better. That's cool, Fidro. That is cool. Yeah, I've never done that. However, Fidro, I don't want to say I've made, but I have used, I don't think they call this an amalgam. They call it an alloy. It's a liquid metal alloy called Gallinstan. And I'm pretty sure I'm the first person to put a video on the internet of Gallinstan undergoing those very interesting chemical reactions where the Gallinstan liquid kind of makes these finger tendrils grow out into solution. I'm not the first person to do a video on Gallinstan by any stretch, But I do believe I'm the first person to do the chemical reaction of Gallium that causes, surface changes, surface tension changes on the surface of the liquid, and that causes these very interesting protrusions to grow out of the Gallium liquid. You're going to want to check out my YouTube videos on that if you get a chance. That did quite well. I think that one hit like 12 million views on one of my YouTube shorts. And my long form they don't do quite as well as my short form. Look at it, we got a little rainbow, baby. Come on now. That's what I'm loving. I'm adding acid to the flask on the right now. A little flash of the rainbow. How you doing there, Mist? We're going to add a little acid over here on the left. There's 1 drop. There's 2 drops. Hello there, Ezekiel. There's 3 drops on the left. There's 4 drops on the left. Little flash of colors. 6 drops, 7 drops, 8 drops. All right, let's see if we can get a rainbow action going here. Here we go, baby. All right. 1, 2, 3, 4, 5. Give me a rainbow. There it is. Give me the rainbow, baby. So Ryan says, fun fact, gallium and aluminum are both illegal to bring onto airplanes. Indeed. Even in checked baggage, because they certainly can cause catastrophic of the aluminum frame of the airplane. Absolutely, man. Don't get caught trying to bring some of that stuff on an airplane. You don't even want to try to bring Gallium on board. Gallium happens to be a liquid metal alloy of gallium, indium, and tin. Yeah, that is a fun fact for sure. Thanks for breaking that into the chat. Let's try to get the static rainbow over here on this side. So let me just do a couple drops of acid over here on the left first, trying to get some color shifts over there. Sure enough. And then we're going to turn this one off here. So I've turned this one off. Oh, look at that gorgeous rainbow over here. We got some nice rainbow action. Over here on the right, I'm going to add a few drops of base. Here we go. 1, 2, 3, 4, 5. Let's just see what happens. We're just going to let that sit. See what happens over here on the right. Thank you there, Daniel. Appreciate it. And while this one's cooking, we're going to go ahead and add a few drops of... Oh, I'm adding acid. Let's add a little base. So Ryan's saying the reaction is awesome. What liquid and base liquid am I using? So by marker liquid, I believe you're asking, about the colors. The solution in here is just water. Boy, that was a nice rainbow color we got there. But this is just water with universal indicator. Universal indicator happens to be a mixture of 4 different dyes, and all of those dyes change color depending upon pH. The 4 different dyes happen to be called thymol blue, methyl red, bromothymol blue, and phenolphthalein, and they all show slightly different colors at different pH values. Now, the acid that I'm adding, this stuff here, this is hydrochloric acid. Looks like I added too much base over here on the right-hand side. I'm going to add a little acid over here. The acid that I happen to be adding is 20% by weight hydrochloric acid. Now, hydrochloric acid is the same acid that's found in your stomach. It's just that, your stomach acid is much more dilute than this stuff that I'm adding over here. The base that I'm adding is called sodium hydroxide. Some people call that lye. Justin taking the Gen Chem 2 right now. I love teaching Gen Chem 2, Justin. What a great class. I hope you're enjoying it. All right, let's cut this off over here. And I'm going to try to add some base over here. This time I'm not going to try to add quite so much. I overwhelmed it with base. How you doing there, Abigail? All right, let's add like 2 drops this time and see what happens. So I've added 2 drops of base over here, and we've kind of cut the stir bar off. We're going to add a few drops of acid over here on this side. How you doing, Jemiah? Great to see you. Forgive me if I pronounced the name wrong. Hello, Ozzy. Welcome aboard. Happy birthday. Which one is it, Jemiah? Come on, everybody wish Jemiah a happy birthday. Which one is it, Jemiah? If you feel comfortable letting us know. Yeah, absolutely, Ryan. So... Ryan, I'm telling you, Ryan the chemist, Ryan the closet chemist has made sure to let us all know that the sodium hydroxide that I'm adding is indeed a precursor, part of what you need to make soap. you react sodium hydroxide with oil, and it makes soap, indeed. Thanks for wishing Jemiah happy birthday, everybody. Puns. You're right, Puns. You are right. It's all fun and games until you actually have to do the titration and draw the dadgum titration curve. And what's worse, of course, Puns, is when you have to calculate the pH at the equilibrium point of a titration, yeah? Thank you there, Jemiah. Which one do you like the most? Those of you who know what I'm talking about, man, who know what I'm talking about, calculating the pH at the the equivalence point of a titration. Man, is that hard. So Fidero was asking, I wondered if liquid nitrogen was negative 327 degrees Fahrenheit. I think it's minus 321, and basically freezes anything it touches. Then what would happen when you put a couple drops into water? So Fidero, go in and look at my shorts and my long form videos as well, and you will see some videos where I explore this in detail. So what happens when you mix water and liquid nitrogen? And it's pretty cool, man. Hello there, Abigail. Puns has got some PTSD. So Ryan says they have no idea what a titration is. Would you please explain? Sure, Ryan. This is what we're going to do over here. We're going to do a titration on this side over here. I'm going to go ahead and mix this up. All right. We're going to do this on the right. This is not a real titration. It's just for demonstration purposes. All right. And then, Ryan, what I'm going to do is I'm going to add a little excess of acid over here. That's what I'm adding. So there's quite a bit of acid in here. And let's say I just happen to, put in a carefully measured amount of acid in here, okay? I'm loving tornadoes too, Illinois. All right, so let's say I took like 10 grams of orange juice or something, and I put that 10 grams of orange juice in here, and it turned this red color, okay? And then what I would do is I would say, okay, let's say that we know precisely that this is, the 3 digits we'll say. I know this is 20.0 grams of sodium hydroxide for every grams of this solution. And this is what you do in a titration. You make what you call a standard, where you know what the concentration of the standard is, as best as you can, of course. Nothing's ever known perfectly. Okay, then what you do is you find the mass of this. And then you start to add drops. I'm going to add a drop here. And you can do measurements by volume, or you can do, measurements by mass, either way. And then we're going to, let's just say we're going to carefully measure the mass of this that we added. I already added a drop. Let's add another drop. So there's a second drop, and each drop has a certain mass to it. And I'm just going to continue doing this until the acid is neutralized. And because I know the chemistry, the chemical reaction of sodium hydroxide reacting with the acid that's present, by knowing there it is, I neutralize it. I actually went a little bit too far. But since I know how much of this I added, I can figure out how much of the acid was originally present. That's the way titration works. I hope that's clear. Yeah, I was trying to go for green here, but I overshot and went to blue. That happens a lot. 4 drops was it, man. So let's do it on this side. Let's do a titration over here. There's an excess of base, and I'm going to start adding hydrochloric acid to it. And we want to try to add the acid until it turns green. I'm going to add 1 drop there. Let's see what happens. You're right, Kyle. There were 4 drops is all it took. You can see in the middle, the acid tends to stay concentrated there. Okay, there was 1 drop. Let's do the second drop. There's a second drop. All right. I think we're going to need another one. I got to wait till all that red stuff disappears. Adriana, I hear you. That the end point is a bit subjective, but if we're talking about drops, you're adding tiny amounts. All right, here's the 3rd drop of acid. And it goes. I imagine you could do that, Ryan. Although I'm not real sure. I'm not sure with engine oil. It depends on what you're looking for. You didn't expect to find chemistry in your meme-ridden shorts feed. That's funny, Zarian. Okay, here we go. This is the 4th drop, yeah? In goes the 4th drop. Hello, Ducky. In goes the fifth drop, probably a bit prematurely, but I'm going to add it anyways. There's the fifth drop. Hello, Lucas. Hello, Carl. We're doing a titration. All right, in goes drop number 6. We're trying to get to green. Drop number 6. Oh, baby. Hello, Ducky. Hello, Cowery. 7's coming up, Abigail. We're getting close. We're at blue. Here's drop number 7. What do you think? Thank you there, Lucas. Hello, Marino. Hello, Bendy. Hello, Sa. Oh, yeah. If you watch Now Red, my channel's going to show up at some point. All right, here comes drop number 8. We're doing a titration there, Vil. There's drop number 8. Hello, Leon, Kivi. Panindra, sorry I'm saying your name wrong. There it is. We got the 8. Got it there, Ryan. Hello, Cloudscape and Obito and X Gaming. I love the color too. Hello, Leon and Francis. Hello, Madison. Thank you, Lando, for the subscription. I'm reading through the comments here, trying to keep up here, so it may take me a bit. You guys are wanting me to do one more. Okay, here we go. One more. There's number 9, and it goes. So we are probably past the end point now. The end point's when it's green. Thanks there, Science or Bust. Thank you there, Marino. A314. You got it, Kivy. Here comes number 10, and it goes. Boom. Number 10. Looks like it took us 10 drops to get us to orange. And I'm guessing 11 drops. Hello, acetylene. To get us to, there's 11 drops. That might get us to red. I agree, Francis. The color changes are very, very pretty. All right, now let's go in the other direction. I'm going to start adding some base. Sodium hydroxide base. Here we go. 1 drop of base, and it goes. Whoop. In goes the drop. Zarian, the pHs are here. So right now we're at about pH 4. You see how there's an orange color? You can see that, you can see the different colors there on the pH scale. I'll leave that down there. What did I do? 2 drops? I can't remember. Am I on 1 or 2 drops? I think I'm on 2. So we're going drop number 3 now, unless you all correct me. In goes drop number 3. Hey, Leo, what's going on? Glad you're doing some science with us, Leo. So it looks like 3 drops got us to pH 8. Is it possible to take the acidity too far and destroy the indicator dyes? I'm not sure. No, Wet Moist, this is not expensive. It's not for fish. It's just for fun. Here we go. You're welcome. You're welcome there, Leonardo. There's another drop of base. What's up, Jonathan? What's up, Aiden? What are we learning, Onyx? We are learning about acids and bases. So I'm doing some, right here in each flask, I have some universal indicator. Universal indicator is also known as rainbow indicator. It's going to display a variety of colors depending upon pH. And pH just tells you how acidic or basic something is. So you can look at the pH scale right here. And I'm going to turn on this light so you can see it a little better. So you can see this flask over here is pH 10, which is actually quite basic. This flask over here, I'm going to say is like a pH maybe 8. Those colors match. So this is actually much less basic because the pH scale works on powers of 10. So because the difference between 10 and 8 is 2, 10 times 10 is 100. So the difference in basicity of these two is 100 times. This is 100 times more basic than this. If I get it to green, that's going to be neutral, neither acidic nor basic. And again, thanks for the thumbs up there, Dark Matter. And if, as you get into this region, you get into acidity. Now, on the acidic region, the lower you get on acidity, the more acidic it is. So pH 3 is 10 times more acidic than pH 4, and so on. So that's what we're doing. That is what we're doing. Thanks for the sub there, Aiden. I appreciate it. Let's get back to doing some of these color changes. Come on, Onyx. Thanks for the subscription. Here we go. Hello, Finley. Hello, Graham Keeler. I am a scientist, Nikki. I am indeed a scientist. But, you know, this scientist can't figure out how to turn off the light. Can't figure out how to turn off this light. What did I do? Why is the light stuck on? Yeah, the control is dead. What did I do? Oh, curses. Yeah, I'm just going to have to turn it this way. That's what we're going to do. I'll just turn it back and forth. Here we go. Let's start adding some acid. Here we go. Over here on the left, added 2 drops of acid. Watch those color changes. Nikki, I got it measured a long time ago. I measure somewhere in between, 120 to 150, depending on the day. Hello, Yash. Thank you there, Phoenix. Hello, Dark Matter. Abigail. Hello, Zook. Hello, Kyle. How many scientists does it take to change a light bulb, Kyle? I want to know. I do agree, Silver Gaming. It is a little weird that Coke has such a low pH. Wherever you mix the base or acid in a universal indicator, what happens inside on a molecular scale? All right, Fidro asking the theoretical question. So you're all going to have to forgive me just for a bit here. Yeah, that's right. Coke is acidic due to the carbon dioxide that's added. What happens if you keep adding the base at 10? What happens? Here, we'll go. I'm going to keep adding. So let's go ahead and make it pH 10. What acid am I adding? I'm adding hydrochloric acid, which is the same acid that's found in your stomach. You guys got to see a flash of the rainbow over here, which is beautiful when that happens. I'm going to keep adding. Okay, here we go. So now we're at violet, yeah? So we're at violet. The issue is that once we get to violet, as I continue to add the base, you can see I'm still adding it. It stays violet. So what we basically say is that pH 10 and above, it's going to be violet. I don't know there, Aiden. I have no idea. Let's start adding some acid now, hydrochloric acid. Make it orange, says Ducky. That's a tough one. We're going to try. Ducky, yellow's not so hard. So I'm going to add to this red one over here. I'm going to add some base, and that'll make the pH go up a little bit. There's your yellow. There's your yellow. Isn't that crazy, Zarian? I totally agree with that. Zarian, the biologist or biochemist, whatever that happens to be, has mentioned that there's a lining of mucus in our stomach, basically snot, that lines our stomach and protects it from being consumed, torn up by the acid. I agree, man. El Assassin, that's totally why I do them, to escape from the world for a while. I'm glad you're on board here. Rika, the base I'm using is sodium hydroxide. That's a good question, Fidro. When am I going to do something different? That's fair enough question, Fidro. I don't know. And I do some different experiments. I do. But this is my go-to for sure. What indicator I'm using, Fennec? I'm using universal indicator. All right, Crab wants blue or green. So I'm going to start adding some acid to both flasks to lower the pH a little bit. Hello there, Zook. People are wanting green and blue. Sergio, this is hydrochloric acid that I'm adding. So as I try to lower the pH, I'm going to add acid. All right, I got to add a little more. We're going to add a little acid over here, a little acid over here. The acid I'm adding is hydrochloric acid. That's right, and I'm using sodium hydroxide as the base. I'm going for green or blue. I'm trying. Where do I get the acid from? There's your green, by the way. I get the acid from, I go to the hardware store. I know what I'm looking for. Oh, hey, Youthan. Youthan, thank you. Youthan sent a gift, which I greatly appreciate. It's not necessary, but I definitely appreciate that. You're welcome, Coyote, although I don't think I was the one that answered. Can I change it to every color, says Edward. Let's give it a shot, Edward. Come on, baby. Can I do yellow or red? Yeah, we can do yellow or red. This would look cool as a table decoration. Look at that. We get a flash of every color. Come on now, look at that. How do you make it spin? I just stick it on a magnetic stir plate. So this thing, it's got like a magnetic fan in it that spins. And then there's a magnetic stir bar in the flask. Yeah, next, this is a neutralization reaction. All right, let's keep adding acid to both. And you're going to see as I add the acid how the pH drops. Here's your pH scale right here in the middle. Hello, Zook. Can I make dark green? I'm not sure I can make dark green, but I can try. Thank you there, Onyx. My day is going good, memes. Hey, thanks there, B. Quaro. I'm glad you think it's normal. My wife doesn't think I'm normal. Have I made a superconductor? I haven't made one, but I play with one. So that I have one that I've made some videos about. I think there's a good long form that I have where you can learn, some into a fairly deep level what's going on with superconductors. Happy birthday, Mystery. Doofenshmirtz, huh? I'm doing all right. I'm Dr. Doofenshmirtz today, huh? So long there, Dark Matter. What are my thoughts about a do-it-yourself cryo cooler? My thoughts are, I'm not sure I can pull that off. Those are my thoughts. They are, Sinbad. I love the color transitions. How do the colors switch? Ask Chi-Chi. How do you do that? So let's talk a little bit about how this is done, all right? So how this is done is I just take some water, and to that water, here, let's just show you. Let's just show you from straight up, all right? Do I have a flask? Maybe I can show you how we start this. Come on, man, where's a flask? I think I can show you this from start. Yeah, this will work. It's going to be a little different shaped flask because I don't have another one of these long ones here, so forgive me. So yeah, we'll just show you how this works. I'm going to stick a little flask on here. And to this flask, I'm going to, you know what, let's do a little differently. This one I'm going to add a really tiny stir bar. So that's really small in there. All right, we're going to turn that stir bar on. Woo, man, that thing's having a hard time. That little one might not work. It might work better if I get some water in there. Okay, now, to this flask, I'm going to add some essential water, which you'll notice that essential water, they say, is pH 9 or higher, 9.5 or higher. You see that? That's what they advertise. So let's put some essential water into this flask. I might have to get that stir bar out. It may not work, but we'll see. In goes the essential water into our fancy hourglass flask. And you'll notice when I do that, the stir bar starts to stir a little more smoothly. Let's pour a little more in, okay? And now to the water, I'm going to add something that we chemists call universal indicator. I like to call it rainbow indicator because it displays all the colors of the rainbow that you can see here, depending upon pH. Now, pH just tells you how acidic or basic something is. So I'm going to take the universal indicator. You can see it right here. Universal indicator. I'm going to take some out. And you see the color is green, right? So it's neutral. All right. I'll show you the bottle again in a bit. And you guys have to forgive me. It's hard to read the comments right now as I'm setting up the experiment. I'm going to go ahead and add the universal indicator. And look what happens when I add it to the water. It turns violet. Now, why does it turn violet? Well, because the essential water indeed is it's truthful advertising. Yeah. It's going to be pH 9.5 or greater. Sorry, it's hard to see that there. Where can you see it a little better? It's hard to see. There it is. It's easy to see up there in the red. There we go. So you can see it there. pH 9.5. So we look at our pH scale, we would expect something to have a pH 9.5 to be like a blue or a violet color. And indeed, that's what we're seeing. We are indeed seeing that. Now, it takes a little while to get mixed up because our stir bar is so stinking small. I'm going to go ahead and add a little more universal indicator in there. That's beautiful color. Absolutely beautiful color. And then the universal indicator, this mixture of dyes, if you look at this flask over here, I'm going to add some base over here. Look, the pH is low. I'm going to add some base. And as I add base, the acid gets neutralized. Actually, I added enough base that went all the way to basic. Let me add some acid to this at the high pH. Oh, look at those colors. Bases, Barak, bases tend to taste bitter, but nice, you nailed it. You definitely nailed it on the sour. Acids taste sour. Now notice over here, this flask has a green color. It's a little bit blue, but that's going to tell us that the acid and base have been neutralized over here. Thank you there, Lydia. Can I explain photophysics? Oh, jeez. Probably not in a YouTube live, huh? Hey, thanks there. Yeah, water with a high pH is definitely corrosive. Thank you there, Abigail. Thank you there, Chaotic. Okay, here we go. We're going to add some acid over here to this flask on the left. So there goes a drop of acid. Let's watch what happens. I'm going to turn this around because I think the colors are more beautiful. You can see them a little better. Look at how the red color from the acid is going through. Now, the acid and base are reacting with each other. And when they sort of equalize, we'll see what pH they end up at. Thank you there, Nova. When I touch the liquid inside, will something happen? Probably. Hey, look it up here at the top. There's like a level of red up. That is gorgeous. We're seeing some interesting effects going on for sure. Wow, there definitely is like a region of acidity right there at the top, which is really kind of cool. So the question is, hey, this is pH 9.5. Isn't this going to be corrosive? Well, there's a couple things to keep in mind. There's not a whole lot of base in this, like a really tiny amount. You can get something to have a fairly high pH without including a large number of, we'll just say, base molecules. Can I demonstrate convection currents? That would be fun, but I don't have the setup. Hello there, Story Shift. Let's add a couple drops of acid over here on the right. The pH indicator I use, Mex Gain, is universal indicator. It does look a little bit like a tornado. Is that right? Ryan, a 1-to-1 mixture of acetic acid and ascorbic acid will destroy universal indicator. Interesting. I'm guessing so ascorbic acid is an oxidizer. So Chino, pH 10 plus will be caustic. Same with acid, so corrosive. I see. Well, I'm guessing that you could probably consume a small amount. You know, the deal is this really is pH 9.5, and they sell it and people drink it. And the reason why they can get away with that is because the amount of base in here is so minuscule. That, you know, as soon as it hits your stomach just tears it up. It just turns it to it just lowers the pH really quickly. Here we go. Let's add a drop of base to this side, drop of base to this side. What I like about this flask over here is the reaction goes quite slowly. Over here, it's rapid. Can I make the acid go to the max level of acid? Let's go for it. Here we go. Over here, I'm going to add a bunch of drops of acid over here. Compare the properties of sulfuric acid and sulfurous acid. So borac, that's going to be the difference between what we call a weak acid and a strong acid. A strong acid is going to do what we call completely dissociate. So basically, it's going to, every single molecule of the sulfuric acid is going to act like an acid, a proton donor. But the sulfurous acid, the H2SO3, will not. So what's going on, that angry British kid? What we are doing is we are adding either base, which I'm just adding to this flask over here, to universal indicator, or I'm going to add acid to universal indicator, and we're going to watch what happens. Lydia, I do have some bromothymol blue, but it's mixed in with everything else in the universal indicator. What would 2 do? You know, pH of 2, it depends on the particular acid, but a pH of 2, like your stomach acid is like pH 1.5. So, you know, basically whatever stomach acid's going to do to you, something with a pH 2 is going to roughly do the same kind of thing in terms of what an acid can do. No, Farhan, I'm not making any of that stuff. That's a different old man. Thank you there, British kid. I'm adding hydrochloric acid to both flasks right now. I thought I left chemistry for good. Why are you bringing me back to it? Oh, Mr. Work. Well, I'm glad you think it's elegant and exhilarating. No, but here's the deal. So people ask, can the pH 9 water neutralize acid reflux? No, it can't. And the reason why it can't is because there aren't enough base molecules in this water to do the trick. So if you want to understand this in greater detail, I want you to Google, can alkaline water change your body pH? And there's an article that I wrote on something called ChemEdX, where you can look at this problem in great detail. What's causing the whirlpool? This is on a magnetic stir plate. What would 0.5 acid do? So pH 0.5. At this point, it depends on the acid. So different acids do have different chemical properties. The common chemical property of all acids is that they do what is called donate protons. And the pH basically tells you the concentration of protons that are in the solution. And the more protons you get in solution, the more those protons can do their work. Oh, that sounds neat. Nilo, I've never done that. Yep, so I hate you. There's a couple differences between the glasses, the stir speed, and you'll also notice that this has a larger stir bar, and this one's much smaller. Can I make it go from green to purple? Let's try it. They want dark red, too. I'm getting a little behind on the comments, so we're going to go really dark red here. That's correct. It's universal indicator, Chris. Can I add baking soda? I'm looking at I cannot. I don't have any with me on hand. I apologize. All right. Let's see if we can get this to go to green. Nilo, so if you want to see that, I can do that. I've done it before. I do it in an experiment called, I get that a lot, Oreo. I do this in an experiment called the bucket launch. So what we do, what's going on, Megan? So what we do is we take some liquid nitrogen and we put it in a Coca-Cola bottle, and then we seal the Coca-Cola bottle. This is very dangerous, all right? This is something that I make sure that I have proper safety protocols going on. But then what we do is we cover the bottle. Well, first we put the bottle in a can with warm water. Then we put on top of it a 5-gallon pail that's reinforced with duct tape. And then we run and watch. Why do they call it universal indicator? Because it shows the universe of colors, red through violet, and that changes depending upon pH. So if you're interested in that, Nilo, just go check out my YouTube shorts and look for the one that talks about the bucket launch. I got a couple in there where we do the bucket launch. Nice there, Lydia. Come on, this is the kind of stuff you do, Lydia. Do experiments for those kids. They're going to love it. What I love about doing experiments is you really don't need to say anything. You just, the science speaks so much more loudly than anything I can say. I mean, I could probably shut up, and I've done this sometimes, where I just add stuff, and you just watch. Oh, Chris, you got to get some universal indicator, especially if you're a teacher. It works really well for a lot of experiments. The universe of the visible spectrum variant. Make that red one go purple, and then add water in it. Here we go, Mr. Work. We're going to make this purple over here. Let's see if I'm adding the right stuff. No, that's acid. Hold on. That's correct, John Doe. Phenolphthalein is an indicator. And in fact, it is one of the indicators in universal indicator. Universal indicator is a mixture of 4 different indicators. Thank you there, Nut. Appreciate that. Can I make the smaller one go faster? Let's try it, baby. Come on. I can't make it mix faster. Thank you there, Space Kid. I remember you, Megan. All right, here we go. Let's start adding some acid over here. They want this one to go from purple to red. Quick. I forgot who asked, but there we go. Purple to red in a flash. I'm going to turn the stir bar up over here. I'm going to see if we can get this going to max speed. Do I know any acids or bases that react to electricity or light? Just about all of them, Fidro. If I put liquid nitrogen and baking soda in a watermelon, and I just watch... Sorry there, Nilo. I don't understand the question. So Wesley, I have done this on my channel. So if you want to go to my long form YouTube videos, and you can see where I add acid to. Actually, I add acid to the different bottles. Is what I do. So Wesley, please go do that. You can see that happening. All right, I agree there. I like the one on the left too better, Mr. Work. I wish you well on your tests. Thank you there, Megan. Can I mix raw pH 5 with a base? I got to get it to pH 5 first. You know, I think I've got it here. I think I got pH 5. The device that spins is called a magnetic stir plate. All right. So what was the question? We got pH 5. We want to mix it with some base. All right. So we got pH 5 here. Yeah. pH 5. Thank you there, Megan. pH 5. Right. And the question was, let's add, that's orange, pH 5. We're going to add some base. Here we go, baby. Here we go. What happened? I dipped the finger in there. Probably not a whole lot. All right. In goes the base. In goes the, look at that. That was just a sweet color change. Hello, Jay. You got it, Starry Night. Let's add some base over here on the right. We're having a good time here. What's going on, Angelina? What's going on? So I want you to, I've taught at 2 different institutions, so I want you to put heart emojis with the colors of the institution I taught you at. I think I know which institution you're at. I just want to make sure. I'm guessing green and yellow. Can I dip my fingers in the liquids? I can, but it's just not good practice. So I'm not going to do that. Sorry there, angry British kid. How come the right one has a vortex thing? Great question. Okay, let's get it so we can see it a little better. So they're both on magnetic stir plates, but the one, look at this. The one here, I'll stop the stirring. Look at how large this stir bar is compared to this one over here. This one's tiny. Here, I'm going to go ahead and try to turn this up. Maybe we can get, yeah, that's what I thought, Angelina. Angelina, I'm just doing the reaction with universal indicator. I did it in class for you guys. I'm just adding acid or base to universal indicator. So we're changing the pH. And Angelina, I'm adding sodium hydroxide, one of the strong bases. Here, let's add a drop over here. Drop a sodium hydroxide for Angelina. Oh, nope, I lied to you. That's hydrochloric acid, one of the strong acids. I messed up. That's not the first time Angelina's seen me mess up. What's going on, Megan? What if I melt uranium? Nilo, I don't know. So long, Lydia. Thanks for joining us today. So yeah, that's what we're doing. Why did it make it yellow? Because the pH was 6. You're going to make different colors depending upon pH. If we hit pH 6, it's going to go yellow. I don't understand the question, Megan, but sure, I'd love to hear that. Did I try to melt gold? Coco, I've not tried to do that, but I did test a metal token that looks like a coin for gold. That was kind of fun. What's the difference between acid and base? The difference between acid and base. So an acid, chemically speaking, is a proton donor, whereas a base is a proton acceptor. That's the difference. They kind of go hand in hand. How's the water spinning? It's there's a magnetic stir plate that it's sitting on, and then there's a stir bar, a magnetic stir bar inside the flask. This one over here, I just got it setting. This one's static, so this one's not spinning at all. I'm going to add another drop of base over here. We may get some cool stuff happening here. I'm going to see if we can get the pH gradient going over here. How do you have acid in your stomach, but when you touch it? Great question, Coco. So in your stomach, there happens to be some mucus that your stomach makes. It's basically snot. I mean, it's the best way to say it. And that mucus lines your stomach, and that keeps the acid from attacking it. Kind of cool, huh? I'm old, man. I'm 57 years old. 57 years old. I'm an old dude. I think I'm going to add another drop of base over here. I think we might get the pH gradient. The left one red, Amy Watkins, is for you, Amy Watkins. Oh, that's the acid. Amy wants the left one red, and Amy's going to get the left one red. Here we go. Here we go. 1, 2, 3 drops of acid should do it. Thanks, Angry British. I'm glad you think so. Hello, Jesus. Hello, Sam. You got it, Amy. There you go. There's the red. That's for Amy. You're welcome. All right, let's add a little drop of base over here. 1 drop. Boop. Look at that one on the left. Just kind of doing its thing. That one guy, I do experiments where I add potassium to water. Check that out in my YouTube shorts. What happens if you put the long stir bar in the short glass? Well, let's find out, all right? Let's do it. I don't know. Ah! I just lost a couple stir bars. Come here, buddy. Here we go. Hello, Thomas. I missed it. No, I haven't. There it is. All right, so there's a long stir bar. Let's take this little one out. There we go. Put the little long one in there. Let me get this going. Oh, it's okay. You have to be strong even if you're 50 or something. Yep. That's correct, man. That's all I'm doing, Samuel. That's all I'm doing. I am just mixing acids and bases with universal indicator on the stir bar. The secret for the beauty, I mean, it is absolutely beautiful. The secret is the backlighting. That's what makes everything look so nice, in my opinion. I think about that kind of stuff. Here we go. Let's add a drop of base over here. Oh, look at that. Little rainbow action. Little rainbow action. Come on, baby. Look at that rainbow. There you go, Megan. It's purple. Thank you there, Amy. Anything solid in my arsenal? Hey, check it out, man. We're starting to get the pH gradient going here. So long, Nova. Thanks for joining in. Great having you. Nilo, I'm not going to be dipping my finger in there. It's not good practice. But nothing would happen. Nothing would happen. There we go. I have, Mighty Mouse. Have you? I've actually I've published an article on oscillating chemical reactions in the Journal of Chemical Education. You know how they give them like names, the oscillating chemical reactions? They give them names like the originator and the Brussellator. We call this one the educator. Mighty Mouse. You might want to check that one out if you're into that kind of thing. Ah, Mr. Work. Yeah, this one's going nice. I kind of like this effect over there. Look at this, guys. Right there in the middle, you can kind of see like the pH green in the middle, which is cool. Thank you there, the cringy crickets. Can I turn up the spin so it looks like the bubbles are getting slapped by the spinner? Let's go for it. Here we go. Can I add a hint of vanilla? I don't have it, that one guy. There you go. There you go. I hope I got what you asked for. Samuel over. The BZ, we call it the BZ reaction. It's an oscillating chemical reaction. I am a teacher, Angry. Oscillating chemical reactions are reactions that like they just shift back and forth, without you doing anything. You just kind of watch it. Here, you could kind of call this an oscillating chemical reaction because it's oscillating between violet and red. But in order for this to be happening, I love my job, Amy. In order for this to happen, I have to add stuff. What's the craziest reason I had to tell a student off in school? Yeah, we probably ought not put that in a YouTube chat. Here we go. Look at this over here. Look at that. Isn't that cool? Got a little pH gradient going on there. What's cool about this? Let me talk about this a second. This is kind of neat. If you like mathematics, all right? So I'm going to show you the pH scale here. Yeah? And so up here at the top, we've got a pH of 3, and down here at the bottom, we got a pH of 10. Thank you there, Samuel. All right? So what's cool about that is, remember, the pH scale works on powers of 10. So what that means is pH 4 is 10 times less acidic than pH 3. pH 5, well, 5 and 3 have a difference of 2. 2, meaning 10 times 10, because this goes on powers of 10. 10 times 10 is 100. So a pH of 3 is 100 times more acidic than a pH of 5. Thank you there, Life is Good. Now, because of this, in this very flask, we've got pH 3 up here, and we got pH 10 down here. Well, that's a difference of 7. So to find the difference of acidity between the top and the bottom, we got to go 10 times 10, 7 times. Well, 10 times 10 is 10, 100. 10 times 10, 7 times. 10, 100, 1,000, 10,000, 100,000, a million, 10 million. So the difference in acidity between the top and the bottom of this flask, in this same flask, is 10 million times. Is it safe to drink? Dankify, sorry. It's never safe to drink because one of the dyes in the universal indicator is a laxative. So if you imbibed this stuff, you would probably spend the rest of the afternoon not doing the live, that's for sure, if you know what I mean. Yeah. The same in dollars, I'll never have that either. Hello, Noel. Hello, Noel. Don't sweat it, Megan. Don't sweat it. You don't need to donate. Do not worry about it. All right, let's mix this one up, shall we? So what we're going to do now is on this flask over here, it's very easy to make at home. In this flask over here, we're going to mix the acid and the base. And if they're perfectly balanced, we should end up with a pH of 7, right? If they're perfectly balanced, then they'll neutralize each other. We'll have a pH of 7, which is neutral. So long, Angry. All right. Now, if there's an excess of acid, the color will end up being yellow, orange, or red. And if there's an excess of base, it'll be blue or violet. Hello there, James. So, using the heart emoji of your choice, let us know in the chat what color you think this will be when I mix it up. Let's see what we got. Who's going to guess what? What color will this be after I mix everything up? Show me with the heart emojis. I'm trying to find a stir bar to mix everything up with. We got an orange. We got a green. Hello there, Abdullah. Megan is guessing. We got a purple. We got a red. Zarian's saying more reddish, so Zarian's saying it's going to be on the acidic end. Samuel's going green. Noel blue. Edward red. That worrisome. Pink. We got a green. Oh my goodness, they're coming in. A brown. It's not going to be a brown, buddy. I can't make brown out of this stuff. All right, y'all ready for it? Y'all got your hearts recorded? Hello, Daisy. Come on, Daisy. We got some young scientists here in the chat. I love it. All right, here we go, folks. In goes the stir bar. Let's turn it on and let's see what happens. Let's see. I'm guessing team yellow. That's what I'm guessing. Uh-oh, I think I'm wrong. I think it's going to go on the violet end. What's it going to be? I think it's got a huge excess of base. So those of you who said that this was going to be violet, you got it right, folks. You got it right. Violet it is. Oh, I love it. Yeah, I overloaded the base for sure. Overloaded the base for sure. Rigged. Oh, I love it. Not always, Punto. Not always, but sometimes acid and bases do react to make a gas, just not in this case. In this case, they make salt. I love it there, Mr. Work. Hello, Ozzy. Welcome to the next stream. Hey, folks, I'm running out of gas here. We're an hour into this stream. That's about as much as I got fuel for. What I'm going to do, what I normally do, I turn the video around so you can see my face for the last few moments of the stream. So I stop doing experiments and I just talk to you. All right. Hey, thank you there, George. Though appreciate that. So yeah, if you don't want to see an old dude in his basement, now's the time to get the heck out of the chat. That's for sure. Okay. So that's what's coming. Naoxy, sorry man, you came in right at the end of the live stream. So what I do at the end of the live stream is I just turn the camera around and I talk to folks. So we're not going to be doing anything cool for sure. You're just going to see some old man in his basement. So that's what's coming, folks. If you don't want to see that, time to get the heck out of here. All right. Yeah, that's coming, Megan. Hey, Monster, welcome aboard. Thank you, Giorgio, for the subscription. I appreciate that. Definitely appreciate the subscription, everybody. If you like this kind of stuff and you like science experiments, goofy science experiments, and fun one where you can learn a little bit in a short amount of time, I do a lot of YouTube shorts. Thank you there, loading. All right, let's do it. Let's turn this thing around. Check out the old man and say hello. Woo! Oh, man. Thoughts on organic chemistry? I think it was a blast, but, I took it 30 years ago. Thanks, there, Angelina. Hello, Megan. Hello, Giorgio. Oh, Uncle Scientist, Mr. Work. I love it. Hey, Zarian. James, hello. Hello, Sonic. Thanks, there, Jay the Goat. Thoughts on particle physics? I think it's wonderful. I think it's awesome. I love that the proton is made of 2 up quarks and a down quark. It all fits together kind of cool. Howdy there, that worrisome. What are some acids and bases you can get in the universal indicator to make this effect? So, Samuel, you could use like baking soda. You can use vinegar. You can use orange juice. You can use club soda. There's a lot. Thank you there, Megan. Would it always settle to purple and red, bottom to top like that? Or can it set? It does it differently, Mighty Mouse. So we've done that a couple times. And occasionally we'll get it to where, there's all the way down, you see large bands of each color. That's cool when that happens. Thank you there, DGN. Good night, Ozzy. John Doe, that's cold to the touch because that particular chemical reaction is what we call endothermic. I'll get to you in a second there, Al-Masui. So some chemical reactions, as they proceed, they release energy as heat, and so they feel warm. And there's other chemical reactions that in order to go, they need to take in energy as heat. And those particular reactions, we call them endothermic, endo meaning into, thermic, heat. And so those reactions need to take in energy from the environment to go, thermal energy, and that's why they tend to feel cold. Heck yeah, Mr. Work, I definitely would do that. Hassan, advice for people who want to go into the chemistry field as an undergrad. I'd get as much mathematics as you can, and I would also find a way to love it. Isn't it true? Like if you just keep at it, keep studying it and learn about the beauty of it. Find the beauty in what you're learning. Find interest in it, and if you're interested in something, you're going to learn more about it. If you love it, if you love something, you're gonna want to be motivated to study it. That's cool to hear, there, Mr. Work. Okay, that's it for the day. Playful. How can you make science-like things more enjoyable to study? Playful. You do experiments. You tinker. You just goof around. You try to find ways to connect what you're learning to things you can do with your hands. Abigail, so long. Everybody, so long. Thanks for enjoying some of the beauty of science with me. But it's just the beauty of the universe, right? I mean, that's all science is. We're just trying to figure out ways that we can connect to, control, and understand the universe a little bit better. And it's just kind of fun when you can simultaneously observe the beauty of the universe and understand a little bit about what's going on, man. That's some cool stuff. So long, everybody. We'll see you next weekend, and thanks for joining in on this stream. See you next time.